So last chapter, or last section, I should say, we talked about different fractions. And by the way, it doesn't matter what the fractions look like. So like they could be just 1/2 plus 1/4. They could have x's in them. They could have x squared plus 5, you know, and then x squared minus 2x plus 7. Like it could be anything in these fractions. The way we handle the fractions is actually going to remain the same, right? So when we add and subtract fractions, we have to have common denominators. So as soon as you see an addition sign or you see a subtraction sign with fractions, you should already kind of start to think, okay, common denominators. I know. Yeah, I'm sorry. Thank you, Kelly. I just realized it. And then we did, the last section was we were multiplying fractions. And when we multiplied fractions, we had to have no common denominators. We didn't even think about common denominators. We just multiplied top times top and bottom times bottom. But before we did that, we were looking across, or top and bottom. Do these have anything in common that I can simplify? Does this have anything? Does this and this? Does this and this? We were looking to simplify. Then we multiplied top times top, bottom times bottom. And finally, we did division of fraction. And we don't really divide fractions. We would keep, change, flip. And we talked about looking for restrictions twice when we had x's in these. Then we talked about changing it to multiplication and then following these rules. And today, we're going to talk about this. Now, why in the world is Mr. Martin putting all this crap up together? Because kids don't care enough. You don't care. You learn one rule and you try to apply it to all of these different fractions. So maybe you were really good at finding common denominators. So then when you see multiplication and division of fractions, you find a common denominator. When you see this one, you try to find a common denominator. And that's not how we're supposed to do it. Each one of these problems has their own way that you're supposed to solve them. In this box, you should be thinking common denominator. In this box, you should be thinking cross cancel, cross simplify, and then top times top, bottom times bottom. In this one is completely different. Both of these guys, both this and this, are what we call expressions. They don't have any equal sign. So there was a rule that when you have an equal sign, whatever you do to one side, you can do to the other. These guys can't follow that rule. This one over here and this one over here, because they're expressions. So you can't use that. But this one can. In fact, there's a new rule that we're going to learn. Whenever you have one fraction set equal to another fraction, and that's all you have. Nothing over here. There's nothing over here. I feel like a magician. Nothing under my sleeve. Nothing over here. Nothing over here. One fraction equaling another fraction. We do what we call cross multiply. So what that looks like is you multiply this times this, 4x, and you put it on one side of the equation. So this times this goes on one side of the equation. This times this goes on the other side. You then isolate the x because we can in this case, and so x would equal 1/2 if I reduced it, and that would be my final answer. Now the problem is kids like cross multiplying. They see that it's pretty easy, and then all of a sudden I give them this problem, and guess what they try to do? They try to cross multiply. Can't do it in that case. I give them this problem, and guess what they try to do? Because we did do something across from these guys. We cross simplify, but they don't do that. They try to cross multiply, and can't do it in that case. The only time you can cross multiply is a fraction equaling another fraction. And again, I don't care how ugly the fractions are. You multiply the tops times the top, or the bottom times the top in this one, and the top times the bottom in this one, and put them both on different sides of the equal sign. So what do we have in this case? Well, we have a fraction set equal to, technically, a non-fraction. But if we know anything about math, we love changing the way things look, but not their value. So we can say, hey, I can take care of this. I'll make you a fraction by putting you over 1. Now we have a fraction equal to another fraction. Does anyone know, does anyone see something? Before I cross multiply, I want to talk about this. Does anyone know about anything that is not written, but they're there? Anything recognize something that's not written but is there, and it's actually going to be very important for when we go cross multiply.
The parentheses.
Around what?
X plus 4.
There are some parentheses. And Kelly, I saw you kind of light up. Why would that be important for me to think about?
Because, say, like you're multiplying the x plus 4 by 2, you need to distribute it, and you kind of can't if there's no parentheses there. You're going to mess up.
Yeah, because what are you supposed to do with that 2 actually?
Multiply it by both the x and the 4.
And what's that called? Do you remember?
Distribution.
Yes, we are going to have to distribute this. And if we don't have that parentheses there, maybe we would just times the 2 by the x and get 2x plus 4, which is wrong. Or we times it by just the 4 and get x plus 8, which is wrong. What we should do is get 2x plus 8. And that's on one side because that's this times this. That goes on one side. And I personally like putting my variable on the left side. That does not have to be there. And then we would do 1 times 1, which would be 1. This could read 1 equals 2x plus 8 as well. Both of these would be the same. And then what we do is because we have one type of x, we can actually isolate the x, meaning we can get this to say x equals by itself. So we would minus the 8 first. So 2x equals -7. We would divide by 2. And our final answer would be x equals -7/2. Now, is there anyone that sees something that we need to check for? Gotta check something this one.
You have to check for restrictions.
Why?
Because the original like 4 isn't there anymore.
So this right here says, hey, you're not allowed to put x is -4. So I look at my answer. Is this answer a -4? No, it is not. So it's good to go. If by chance, when I solved this, this would have equaled let's say I solved it and it would have been a -4, you would actually throw that answer out, and it's called an exclusion, or an extraneous solution. And if that would have happened, there would be no solution to this question. If x would have equaled -4, we would have to throw that out and actually tell the person, sorry, there is no solution for this question. But it didn't happen. My exclusion was not what we got at the final answer, so that is my answer. Go ahead and try this one on your own. I will be asking for people's help on this one. All right, Tucker, can you help me out with the first step? What am I supposed to do in this one?
Put 5 into a fraction.
So it means 5 over what?
1.
Perfect. Very good. Josh, what would be the next step?
Put parentheses around x minus 3.
Very nice. Much better today, guys. Destiny, what would be the next thing I would do?
I'm not entirely sure.
I've been watching what I did last problem.
Yeah.
What did I do last problem next?
You,
Did you write it down?
no.
So we should be taking those notes.
Yeah.
Sierra, can you help her out? Tia, can you help her out?
Would you distribute the 5?
Yep, and that's part of what? Do you remember what I called that? Since they're set equal to each other, what is this process called?
Isn't it cross
Yep, cross. And then what are you doing when you distribute? You're really,
multiplying?
yeah, so we're going to cross multiply, meaning we're going to multiply these two together, which like you said, you're going to distribute. 5 times x is 5x. 5 times negative 3 is a negative 15. That goes on one side, and then equal, and then you do across 1 times 1 here is 1. Annabella, what would I do next? What's the goal?
To make x by itself,
So what would I do first?
subtract 15, or adds 15.
Good. Whoops. I hate this thing. I don't know why it does that. All right. Then what would I do next, Daniel?
Then you would divide 5 by 5 and divide 16 by 5.
And then your final answer is 16/5. Savannah? Do you know what my final thing I would be doing is? I don't know if you're talking, Savannah. Oh, there you go. Savannah? Hello? I can't hear you. No, it's not working. Good try, though. Thank you.
Mr. Martin,
Yep.
what's that word again that you said when they aren't like when the final answer isn't set equal something exclusion or solution, something like that?
So this one is not one of those because I would check this right here. X
Yeah,
can't
they're
so-
not the same.
X can't equal -5 is an exclusion. This is not that. So that is the answer. Or sorry,
Okay.
that's positive 5. Positive 5.
And what is it
So
called
that's
when
my
they are?
So when this is what I got here, it's called an extraneous solution.
Okay, I'm just wondering because I'm taking notes, so I'm just writing everything.
Yep. No worries. It's called, I love it. It's extraneous solution.
All right,
Basically,
thank you.
it's an extra answer that doesn't work. Is basically what it's saying.
All right.
All right. So when can we do this cross multiplying? Because it's so important. See, that's what I keep trying to tell you guys is that it's like we go through math and you learn all these special powers or tricks or whatever, but you can't just go around throwing them. Like you can't just use it whenever you want. Like there's certain situations that you have to apply this. If you apply your knowledge in the at the wrong time, that's when math gets so screwed up, which is what a lot of us have been doing. We watch and we kind of understand it, but then we apply it in the wrong scenario, and then we're like, I hate math. Math can be very, very like this is when you do that, but it takes a lot of effort to know when to do it. And the thing that sucks is a lot of the math problems look similar. So we get tripped up and we use the wrong trick at the wrong times. It's all about recognizing when you do this, right? So when did we do this cross multiplying? What were the big things that had to happen? Ashton?
Yeah. What
When
was the
did we
question
do-
again?
When do we do cross multiplying?
When they're on opposite sides, like it's not I forgot what you said earlier, but
Look at
it
the
has to have an equal sign in between.
boom. Has to have an equal sign and how many fractions?
2.
Only 2. You have a fraction, you have an equal sign, you have a fraction. That's when we can cross multiply. If there's anything over here, if there's anything over here, we cannot do cross multiplying. Only a fraction, equal, and then another fraction. I don't care what all the stuff is up here. I don't care how ugly each one of these fractions is. As long as a fraction equaling a fraction, we can cross multiply. If there's other stuff out here, we cannot. Does that make sense? Yes, Mr. Martin, it does. Oh, thank you so much. I appreciate that. I think every time you guys don't answer, I'm going to answer with that kind of voice, and that person's going to be called Francis, you know? All right. This is the problem we're going to come up to next. Does anyone know why this one is different than what we just did?
Is there something on the other side?
Yeah, this is not one fraction equaling another fraction, right? There's 2 fractions on one side equaling another fraction. Now, some of you might be thinking, and this is actually not a bad thought, that we could, and this is correct, we could actually find a least common denominator. We could then add these 2 fractions and then make this become 1 fraction equaling another fraction. And finally, we could then cross multiply. However, that would be a lot more work than the way I'm going to show you. So actually what we do in this one is we find a trick that allows us to get rid of the fractions. It's like, hey, I don't like fractions, so I'm going to get rid of them. The rule is, since we have an equation, whatever we do to one side, we just have to do it to the other. In fact, whatever we do to one thing, we have to do it to all of them. So like I can multiply this by 10 if I wanted to, then I have to multiply this fraction by 10, and then this fraction by 10. As long as I multiply all 3 of them by the same exact number, it's Gucci. If I wanted to add 10 to this side, I could do that. If I wanted to just like add a 10 here, I could, but I'd have to add a 10 here. Actually, adding would not help us in this scenario, but I could do it. It would just make my question more jumbled and probably more of a pain in the butt. So it's not for a purpose, right? So let's go to a different, maybe a little easier example. And see how this works out. So what happens is if I times, let's just take a half for a second over here. If I take a half and I times it by a 2, what would happen when I did this would be the 2's would cancel out, leaving me with 1 and a 1, making this no longer a fraction, but just a whole number. So if I times this fraction by a 2, it would cancel it out and make it a 1. No fraction anymore. But the problem is, we said whatever we do to 1, we have to do to all 3 of them. And if I times this by 2 and I times this one by 2, it does not get rid of this denominator, nor does it get rid of this denominator. What my trick is I want to find a number that I can multiply all 3 of them by so that all 3 denominators go away. This is called your least common multiple. It will also be the same thing as their least common denominator. The least common denominator is the least common multiple between all the denominators. So what would be the least common multiple? A multiple is a number that all 3 of these numbers go into. So does anyone know what number all 3 of those go into?
Well,
12.
2.
12. Okay, so I heard 2, which I understand why I heard 2. So 2 is a factor of all of these. That's different. That means that 2 goes into all of these. I'm not looking for a number that goes into all of these. I'm looking for a number that 2 goes into, that 4 goes into, that 6 goes into. That means you could take them each and multiply them by a number, and they could become that. So the smallest, what would be the smallest number that they could have in common? What would be the smallest number that all of them could multiply to become? It doesn't work, but what could possibly be? What would be the first one I would check? Would be 6. I would check 6 to see if all 3 of them, and 2 actually does become it. 4 doesn't, so 6 doesn't work. So then I go 12. 12 does. He was in my other class. You better straighten that out, Parker. $12 does. So what I'm going to do is I'm going to multiply this by 12, this by 12. Parker, hold on one second. Parker. Sorry, another teacher needed to ask me a question about another student. So you multiply this by 12, this by 12, and this by 12. And then what I'm doing is I'm taking the 1/2 and timesing it by 12 over 1. And I'm also taking the 3/4 and timesing it by 1/2. I'm also taking the x over 6 and timesing it by, what did I do? I messed this up, sorry. The 3/4 and timesing it by 12 over 1, taking the x over 6 and timesing it by 12 over 1. Do you see how I'm multiplying each one of those things by 12 over 1? And then what happens is we can cross simplify, which is what we taught last section. This turns into a 1, this turns into a 6. This turns into a 4 goes into that 3 times, 4 goes into that once. 6 goes into this once, 6 goes into this twice. And then I'm going to simplify each one of these fractions. So when I multiply the 1/2 by a 12, it turned into a 6. How? 1 times 6 is 6. 1 times 1 is 1. 6 over 1 is 6. When I did this one, I was left with a 3 and a 3. 3 times 3 is 9 over 1 times 1 is 1. 9 over 1 is just a 9. And finally, this one turned into a 2 times x, which is 2x, over 1, which is just 2x. So all this turned into was a 6 plus 9 equals 2x. Now, we can isolate and get the x by itself. We'll first add those together. That's 15 equals 2x. Divide by 2. And I get 15 over 2 equals x for my final answer. Did that process kind of make sense?
it makes sense.
What did we do? We got rid of our fractions. We took this and made it become that. How? By multiplying by the least common multiple. And what that least common multiple does is cancel out all the denominators. Why? Because all these numbers can go into that number. So they're all going to cross simplify. If I'd used a number that they all didn't simplify with, then I would have been left with the denominator, and this would be pointless. The whole idea was to get it to where it was no longer a fraction. What do I know about this equation up here and this equation down here? They are the same exact equation, just written differently. And when I write it like this, it's much easier for me to solve for x. We're going to apply that same thing here. So what we need to do is we need to find a least common multiple, aka the least common denominator, and then we're going to multiply all 3 of these things by that least common denominator. So First is we're going to factor the bottom. So factor this is what we're doing. That turns into a x minus 3, x minus 5. Well, then I look and I love this one because this has an x minus 5, this has an x minus 3, this has an x minus 3 and an x minus 5. So my least common denominator is going to be x minus 3, x minus 5. And what happens is I'm going to multiply each one of these fractions by this number. So that means I'm going to have x minus 3, x minus 5. I'm going to write it 3 times, 1 for each fraction. And watch what happens. The x minus 5 is in the top, the x minus 5 is in the bottom. Those cross simplify. The x minus 3 is in the bottom, x minus 3 is in the top. Those cross simplify. X minus 3 is in the bottom and top. X minus 5 is bottom and top. Both of those cancel out. And then I distribute with what I'm left because this is all my denominators turned into 1s. All my denominators, I don't know why it keeps going up and down, turned into 1s. So there are no denominators anymore. That was the purpose of this. I no longer have a denominator. So now I would try to distribute this. Since it's a 1, it's really just going to stay x minus 3. I'm going to distribute this x. X times x is x squared. X times negative 5, negative 5x equals, since this turned into a 1, it's just a 2 on this side. Since I do not have 1x right now, I'm going to have to try to solve this by factoring and set this thing equal to 0. So first, I'm going to reorder this so it's in standard form. So I'm going to put the x squared first. I'm going to combine a positive x with a negative 5x, which is going to turn to a negative 4x. I'm going to put this negative 3 behind it, keep the sign with it. I'm then going to say, okay, I still don't have just one type of x, so I am going to have to solve this by factoring, which means I have to set it equal to 0. X squared minus 4x minus 5. This tells me different signs. This tells you the bigger one is negative. 2 numbers that multiply to 5 but subtract to 4. A negative 5. A positive 1. What makes this 0 would be a 5. Whoops. X equals 5. What makes this 0? X equals negative 1. But then I go back and I check my beginning. And what do I notice about this? One of my exclusions is x is not allowed to equal 5. The other exclusions is x can equal 3. Those are the same here. There's no new ones over there. So what do I know? This one says that x equals 5, which we knew is one of our exclusions. So we throw that answer out. That is called an extraneous solution. So this would actually be only our answer. So if on the test I had A, x equals 5, x equals negative 1, B, x equals 5, C, x equals negative 1, D, no solution. Your answer to this question would be C. If they ask me, find the extraneous solution, what is the extraneous solution? And it was multiple choice. The answer would actually be x equals 5, because that is the extraneous solution. So you need to read the question and answer what they're asking you. Sometimes they're asking you for what x would make this work, which would be negative 1. Sometimes they're asking you for the extraneous solution, and that would be 5. So you need to know those vocab words and make sure you're answering the question that they are asking. Does anyone have questions on that? Anything on that problem? So tonight, you don't have any homework. Tomorrow, we're going to go over this some more. We're going to talk about the different scenarios on why we're cross multiplying or why we're not doing that. We're multiplying everything by the same denominator, so the denominators cancel out. So we're going to have more practice on that tomorrow. But basically, this is it. Tomorrow we'll practice. We'll probably have a review maybe Wednesday, go over the review maybe Wednesday in class, which could put the test at Friday or test Monday. So I'd definitely see thinking test Friday or Monday. Questions?
No.